Okay, so get this. Imagine a calculation,
Right.
right? So huge that even if you had the most powerful supercomputer, it would take it like 10 septillion years
Wow.
to figure it out. That's longer than like the whole age of the universe, you know?
Right.
But get this, Google's got this new quantum chip. It's called Willow.
Okay.
And they just did that calculation in under 5 minutes.
That's that's insane.
Yeah, it kind of blows your mind, right?
Yeah.
So that's what we're diving into today, quantum computing. And specifically, we're looking at how this Willow chip is kind of pushing the boundaries of what we thought was even possible.
hmm
So to start us off, can you maybe help us understand the big challenge in quantum computing? They call them errors. What's that all about?
Yeah, so basically, quantum computers, they use these things called qubits.
Right.
And qubits are, well, they're kind of finicky.
Uh-huh.
They're not like the bits in our regular computers, which are just, 0, 1.
Yeah.
Qubits can be both 0 and 1 at the same time. It's called superposition. But the problem is they're super sensitive. Even like the tiniest little interference can mess everything up, and that causes errors.
So it's almost like building a house of cards, but in a windstorm or something.
Yeah, exactly. And for a long time, that's been the big problem with making quantum computers that actually work, practically. But what's exciting about this Willow chip is that it's actually able to reduce errors as it gets bigger.
Hmm.
And it achieves something called below threshold error correction.
Below threshold. It sounds kind of mysterious.
Yeah, yeah. It's like, you reach a tipping point. Below that threshold, you can correct errors faster than they pop up.
Okay.
And that means you can do reliable computations. This has been like the holy grail of quantum computing for, gosh, almost 30 years.
Wow.
And what Willow's done is a massive step forward.
So does that mean that, like, we're close to having quantum computers that can solve actual real-world problems?
Yeah. We're getting closer all the time. There's still work to do, for sure. But what Willow shows is that it's not just a fantasy anymore. Building fault-tolerant quantum computers is actually within reach.
That's pretty amazing.
Mm-hmm.
So let's talk about this benchmark test that Willow just aced, random circuit sampling. What's that all about?
Think of it like a quantum obstacle course. It's really hard for regular computers to get through it. You've got all these random operations happening to the qubits, and then you measure the final outcome. And as you add more qubits, the whole thing gets exponentially more complex.
And Willow got through this in, what, under 5 minutes? And a supercomputer would take in 10 septillion years. It's just mind-blowing.
It really shows how differently quantum computers work compared to our classical computers. Some physicists, like David Deutsch, they even think that this kind of speedup could be a hint that parallel universes exist.
Whoa, hold on. Parallel universes. That's a whole other deep dive right there.
Uh-huh, yeah.
But okay, back to Willow. What makes this chip so special? What's their secret sauce?
Well, Google's philosophy is kind of like quality over quantity. They're more focused on making each qubit really robust and stable rather than just cramming in a ton of them.
Makes sense.
And that's shown in Willow's T1 times, which is basically how long the qubits can hold information.
Okay.
And that's super important for doing these really complicated calculations.
So it's less about like having a huge crowd and more about having a team of like super skilled athletes.
That's a great way to put it. And that focus on quality has really paid off. Willow's T1 times are way longer than what we've seen in previous quantum chips.
Interesting.
And that lets them do more complex computations more reliably.
And of course, we can't forget about the amazing facility where they built Willow, right? That cutting-edge place in Santa Barbara.
Yeah, Google's investment in that facility shows how seriously they're taking quantum tech. It's one of the few places in the world that can even make quantum chips at that level of precision and complexity.
It's pretty incredible. So we've got this super powerful chip, Willow, right? And it's just crushing these benchmarks. But what's next? Where do we go from here with all this quantum computing stuff?
Well, that's the big question, isn't it? Like, we have these benchmarks, like that random circuit sampling thing. They're great for seeing how far we've come.
Right.
But they don't really have, like, direct real-world uses yet. The challenge now is to find those useful computations, the ones that go beyond what classical computers can do.
You know, some people might say that all these abstract benchmarks are kind of distracting us from the real goal, like finding those practical uses. What do you think about that?
I think it's a fair point. But these benchmarks, like RCS, they serve a really important purpose. They let us really test what quantum computers can do. Push the limits. It's like training for the Olympics. You got to have those tough tests to make sure you're ready. And the things we learn from these benchmarks, they actually help us develop algorithms that can solve real problems.
So it's more like a stepping stone then, not the final destination.
Exactly. And the potential applications are huge, like really exciting stuff. We could see quantum computing revolutionize medicine, material science, artificial intelligence, all kinds of fields.
Let's dig into some of those. Like, how could quantum computers actually change our lives, in a real way?
Okay, so take medicine, for example. With quantum computers, we could simulate how molecules interact, but at a level of detail that's just impossible right now. That could mean designing totally new drugs and therapies. Like, imagine treatments that are perfectly tailored to your genes, to your specific illness.
Oh, so that's like personalized medicine. But on a whole other level, what about material science? What could happen there?
Well, imagine designing materials that have properties we can only dream of right now. Think of superconductors that work at room temperature, which would make energy transmission way more efficient.
Yeah, that would be huge. Less energy loss, cheaper electricity, and it would be better for the planet too.
Exactly. And that's just scratching the surface. The possibilities are mind-blowing.
Okay, let's switch gears a bit and talk about how quantum computing could affect cryptography. That seems like a bit of a double-edged sword.
It is. Right now, all our online security, our transactions, communications, everything digital relies on encryption algorithms.
Right.
And some of those algorithms, well, they're vulnerable. A future quantum computer could crack them.
So it's like we have this incredibly powerful tool, but it could also undermine our entire digital world.
And that's why there's a whole field now focused on what they call post-quantum cryptography. Basically, trying to create encryption that even the most powerful quantum computers can't break. It's a race against time, but it's essential if we want to keep our digital world safe.
It really shows how this technology is going to change things in such a fundamental way. We have to start rethinking our digital infrastructure even before quantum computers are, like, everywhere.
For sure. That sense of urgency and the excitement, too, it's everywhere in this field. It's a really cool time to be involved in quantum computing.
Going back to those potential uses you mentioned, medicine, material science.
Right.
What about AI? How could quantum computing impact that?
AI and quantum computing, they're a powerful combination. One of the biggest challenges in AI right now is training those machine learning models.
Yeah.
You need massive data sets, and even for supercomputers, it takes a ton of power.
Yeah.
Quantum computers could speed that up like crazy, which would lead to much more powerful and efficient AI.
So AI could learn way faster, even maybe surpass human capabilities in some areas?
That's a real possibility. It's still early days for quantum machine learning, but it's super promising. Imagine AI that can analyze tons of data, but also actually understand the world in ways we can't even grasp yet.
So we're talking about potentially unlocking a whole new level of intelligence, one that could change how we see ourselves and the universe.
That's a pretty profound thought, and it highlights how important it is to approach this technology carefully with a strong ethical framework.
On that note, there's been a lot of talk lately about the potential impacts of quantum computing on society. Some people worry about job losses, others fear that all this power will end up in the hands of a few big tech companies. What do you think about those concerns?
There are definitely valid and important concerns, ones we need to be proactive about. Quantum computing, like any really powerful technology, has the potential for both good and bad. We need to make sure that it's developed and used ethically with a focus on benefiting society.
So it's not just about building these amazing machines, it's about building a responsible and inclusive quantum ecosystem, right?
Exactly. We have to consider the big picture, invest in education so people are ready for the quantum era, and ensure that everyone has access to this technology, that it benefits everyone.
Now, we've been talking a lot about Google's Willow, but it's important to remember this is a global effort. What other approaches to quantum computing are being explored out there?
You're right, it's a global race with brilliant people all over the world trying to build these machines. Besides Google's superconducting qubits, there's also trapped ion quantum computing, where companies like IonQ and Honeywell are doing some amazing work. They trap individual ions with electromagnetic fields and use lasers to control their quantum states.
So they're not manipulating electrical circuits, they're controlling actual atoms. That's wild.
It is. And each approach has its pros and cons. Superconducting qubits are easier to scale up, while trapped ion qubits usually have longer coherence times, meaning they hold onto quantum information for longer. And then there are other approaches like photonic quantum computing, topological quantum computing, even neutral atom quantum computing.
It's like a giant science competition, with everyone betting on a different horse. But in the end, doesn't everyone win? The more approaches we explore, the faster the whole field progresses.
Absolutely. That diversity in research is crucial. It makes sure we're exploring every possible avenue to unlock the full potential of quantum computing.
It's like the early days of airplanes when people were trying all sorts of crazy designs. Some worked better than others, but every experiment helped us understand flight.
Haha. I like that analogy. And just like with airplanes, we can expect to see lots of unexpected innovations and breakthroughs along the way. Quantum computing is still wide open with tons of uncharted territory and possibilities.
It's exciting and a little overwhelming, too, to
Oh,
think
yeah,
about.
it is. But that's what makes this field so captivating. We're not just building faster computers, we're exploring fundamentally new ways of understanding the universe. And that journey, it's going to lead to some incredible insights and technologies.
You know, it really feels like we're on the cusp of something huge with this whole quantum computing thing. Exciting, but maybe a little scary, too, right?
Yeah, I think a lot of people feel that way. It's like we've been given this incredibly powerful tool, but we're still trying to figure out, like, what we can really do with it.
We've talked about all these potential uses, medicine, materials, AI, even cryptography.
Yeah.
But I'm curious, what are you most excited about? What's your, quantum dream?
That's a good question. I think what really inspires me is the potential to tackle those really big challenges, the ones that affect all of humanity. Like, imagine using quantum computers to model the Earth's climate in a way that's never been possible before. We could predict extreme weather events so much better.
That would be incredible. Especially with climate change getting worse, we could maybe save lives, help protect communities from those really devastating natural disasters.
Exactly. And think about this. What if we could develop personalized medicine, like tailored to your exact genetic makeup? Using quantum computers, we could treat diseases way more effectively, have fewer side effects, and people would live longer, healthier lives.
Wow. It would be like the ultimate preventative care, catching things before they even become a problem.
Yeah,
That's an
exactly.
amazing vision.
Yeah.
But it makes me wonder, will everyone benefit from this quantum revolution? Or will it just be for the privileged few?
That's a really important point. We have to work towards a future where quantum computing is accessible to everyone, not just a select group. That means investing in education and training, making those quantum resources widely available, and building a culture of collaboration and open innovation.
So it's not just about the technology itself. It's about the values and principles that shape how it's developed and used.
Right. We need to make sure that quantum computing is used for good, to solve the biggest problems facing humanity and make a better future for everyone. We can't ignore potential downsides either, like job displacement or the concentration of power. We need to be proactive about addressing those.
It seems like we need a global conversation about all this, about the ethical and societal implications of quantum computing. And it can't just be scientists and engineers talking. It has to include policymakers, educators, and regular people too.
I completely agree. This is a discussion we need to have at every level of society. We need to ask ourselves, what kind of world do we want to create with quantum computing? And then work together to make that happen.
That's a powerful message. So as we wrap up our deep dive, what's the one thing you'd like our listeners to take away from this conversation?
I'd want them to feel that sense of wonder and possibility. Quantum computing is mind-blowing. It's full of mysteries and the potential for huge breakthroughs. It reminds us that we're still learning about the fundamental laws of the universe, and there's so much more to discover.
And maybe even a sense of responsibility too, right? To really engage with this technology in a thoughtful and ethical way, to make sure it's used to benefit all of humanity.
Absolutely. We have this incredible opportunity to shape the future of quantum computing, and we should approach it with both excitement and a deep sense of responsibility.
Well said. Thank you so much for taking us on this incredible journey into the world of quantum computing. It's been truly fascinating.
It was my pleasure. And to everyone listening, thanks for diving deep with us. Until next time, keep exploring, keep asking questions, and keep dreaming big.